Welcome. We're going to be going through our circle study guide today to make sure that we are nice and prepared and can keep all of these topics organized in our head. Let's begin. The first section there wants us to identify major, minor, or semicircles from those arcs and find the measure of the arc. So, looking at arc AD, right? Begin at A, end at D. The arc matches the central angle. So, this is 70 degrees, and anything less than 180 degrees is classified as a minor arc. Then, number two, then wants us to look at arc AB. So we begin at A, end at B. That arc is going to have to match its central angle. We'll have to do a little bit of work to find that. Notice that DC is a diameter, so I know that I have to have 180 degrees for that semicircle. So a little bit of calculation there tells us that 180 minus the 70 and minus the 50 we already have puts 60 degrees at the central angle, which would then mean that I also have 60 degrees as my arc. This is also less than 180 because it's obviously less than the semicircle. That's a minor arc. Next up in part C, we're looking for arc CD. From C to D could come this way, or also notice that CD could also then likewise go the other direction. In either case, you're talking about a semicircle, so that's 180 degrees. Now, do notice there's actually probably a typo here. To be a semicircle, we should probably have 3 letters in that name so that we can specify whether we are talking about the bottom portion or the top portion of that. So perhaps if we're talking about this bottom section where we are, we would need an additional point, maybe F in there to talk about it as an arc of CFD, or if you had wanted it to be the upper more zone of it, maybe then you could have called it arc CBD or you called it arc CAD. But nonetheless, semicircles should have 3 letters in their name. So I hope that you were still able to follow along with that typo. Letter D wants you to look for arc BDC. So we're going to start at B. We are going to go past letter D and then all the way around to C. So looking for all of this. So you could think about that 2 different ways. You could take the 360 for the whole circle and then subtract out the 50 degrees that we are not using, or you could add up the 60 and the 70 and the 180 to cover all of the arcs that you are using. In either fashion, we're talking about 310 degrees there. This is a major arc because that's obviously over 180 degrees. And it has 3 letters in its name. So that's a good clue. Then we look at part E for arc ACD, starting at A, going past C, and ending at D. Again, this one here that I've got in orange, 2 different options for you. Maybe you're going to take your 360 for the whole circle and subtract out the 70 degrees that you don't need in arc AD, or maybe you're going to add up the 60, the 50, and the 180 to get those. You're talking about 290 degrees. That is a major arc. And then the last one to look at is the arc BC. And from B to C, right there, with a nice central angle of 50 degrees, this is another minor arc. As we move on then to question number 2, we were talking about inscribed angles in that figure. So make sure that you are labeling all of these properly. We're looking at angle YWZ. So angle YWZ, this is my inscribed angle. Vertex W is on the circle. That's going to be based off of the arc. This is my ice cream scoop of an arc, right, for the inscribed angle that goes the whole way across. So to find out what this ice cream scoop is, I'm going to need to know about an inscribed angle from this. I can see the inscribed angle is 50. I want to have twice as much ice cream. So we multiply by 2 to get 100 for that arc. Now that 100-degree arc of YZ is going to have to be reduced. That's going to have to be cut in half to get my angle. So I'm talking about 50 degrees. So in that process, we actually ended up answering our part B there about arc YZ. Arc YZ is what we found to be the ice cream scoop arc on that angle. Then we are asked in part C to look at arc WX. So let's see, arc WX and I can follow this. It has a nice inscribed angle. Vertex Y is on the circle. Notice that 35 degrees here. Again, I want to have twice as much ice cream as what I do for my angle of my cone. So with that inscribed angle, I'm going to multiply by 2. 35 times 2 tells me that my arc has 70 degrees in it. And then when we go looking at the part D for angle WZX, from W to Z to X, I have an inscribed angle. Z is my vertex on the circle. The arc of that is still an ice cream scoop with the same 70, so I'm going to have to divide that by 2 to get my angle. That's going to give me 35 degrees. Moving on down as we continue, we've got some tangent lines to circles looking at these angles. So angle 1 is created from the tangent all the way through to the chord, and the arc that you have cut off by that chord is 164 degrees. This one follows that same rule as the inscribed angles. If you remember that the arc is twice as much as the angle, and the angle is half as much as the arc. So we're going to have to take that 164 and divide it by 2 so that my angle 1 is 82 degrees. Part B gives me an angle of 113 degrees. I am asked to find I'm asked to find arc PRQ. So the angle goes from the tangent all the way through to the chord, and I want the arc that is cut off in the same direction from chord endpoint to chord endpoint. So the angle is half as much as the arc. We're going to take that 113 and multiply it by 2. That will give us 226 degrees. And then the part C wants me to find arc EG. So my arc EG, it's cut off from those 2 endpoints of the chord. To find this, I would want to know the angle that's in that same direction from the tangent to the chord. So notice that you have a linear pair. That tangent is a line, 2 angles back to back on the same straight line are going to be supplementary. So what is 180 minus the 135? That leaves you with 45 degrees in this angle. And again, the rule says that my angle is half as much as the arc. So I'm going to take that 45 and we will multiply it by 2 to get the arc size. You're talking about 90 degrees. At the bottom of this page here, we can look at some inscribed quadrilaterals. And so remember that in an inscribed quadrilateral, the opposite angles are supplementary. So in example A, angle R and angle P are supplementary. So 3x plus 6x must equal 180. So that's 9x when you combine like terms to equal 180. Go ahead and divide both sides by that coefficient 9. So I find out that x is 20. Then another set of opposite angles, so angle Q and angle S are also opposites. They would also need to be supplementary. So 4y plus the y equals 180. Combine like terms, 5y is 180. And when you divide both sides by our 5 coefficient, we find out that y is equal to 36. Now, when we come over and start looking at that example B, I want to find each variable. So if I start with W, W is an inscribed angle there, and look at the arc that it opens up to. Notice those endpoints for it. This covers the span of 51 arc and the span of the 79 arc. So you've got to know what is 51 and 79 together. You're talking about 130 degrees in that purple arc. Again, this is an inscribed angle, so the angle is half as big as the arc. So to find that W, we're going to take our 130 and divide it by 2. You're looking at 65 degrees. Then if I go to look for angle X, this is an inscribed angle. Follow those 2 chords out and look at the arc that is formed from inscribed angle X. That's going to be the 81 section and the 51 section. So we've got to be able to add these together. I've got a sum of 132 there. And again, the angle is half as much as the arc. So I have to take that 132 and divide that by 2 this would tell me that x is 66 degrees. If I go looking for y, now inscribed angle y, I can find its two chords. Well, that wasn't my best tracing job there. And then look at the arc that it's formed. So my arc includes the 81 and my arc includes what other amount here? We don't know this one. We've still got to figure it out. So remember, there's 360 degrees in every circle. If I take away the 81 that I know, take away the 51 that I know, take away the 79 that I know, what are you left with? There must be 149 degrees over there. So the arc that I have, the pink arc from inscribed angle Y, that's my 81 and my 149 together. You're talking about a whole span of 230 degrees there. So to find my Y, take that arc, divide it by 2, you've got 115 degrees. And lastly then, we need variable Z. So Z is going to be from the inscribed angle. That's going to cover the 149 and that's going to cover the 79 to get those endpoints together. So 149 and 79 together makes 228 for my arc. So take my arc, divide it by 2 because the angle is half as big. You're talking about 114 degrees. Now, nicely enough, I hope you realize that you could check your answer here because these four angles that we just found are the four angles of a quadrilateral. So if everything went well, these four angles should have a sum of, yes, that's right, 360 degrees. And we do indeed, right, sum of 360 degrees for all four angles in a quadrilateral. So 65 plus 66 plus 115 plus 114 does give us the 360. So you do have that option to check your answer and make sure that it's going well for you. Speaking of the measures of all those angles, I just realized that we never plugged things back in on example A, right? We were supposed to find the measure of each angle after we found those variables. So let's jump back over there and plug some things in. So at angle R, 3x is 3 times 20, so you're talking about 60 degrees. And at angle P, 6x is going to be 6 times 20, that would be 120 degrees. Then angle Q, that's just a measurement of y, so that one's easy. Plug in the 36 and you get 36. At angle S, you're talking 4y, so 4 times 36 puts us at 144. Again, you do have the option to check your answer. 60 plus 36 plus 120 plus a 144 gives you, oh yeah, there it is, 360 degrees. So check those work. Your arithmetic and your algebra are on the right track. So we come on over to part C then, another inscribed quadrilateral now. And if I need to find the value of A and B, so looking at this, my A variable is in angle L. Find those two chords. So I'm looking at the arc MK. Now I know that part of this arc is 54, but I need to know a little bit more. I need to know arc JK. Use what we know about that circle. Every circle has 360 degrees in its sum. Subtract the 54, subtract the 130, and subtract the 110 that we do know. So arc JK must have 66 degrees in it. This tells me then that the arc MK that I am looking for is going to be the 54 and 66 together. So I'm talking about 120 degrees over there. So what are you going to do to set up your equation then? My angle of 3A is going to need to be multiplied by 2 in order to get that 120 degrees of arc. So if 6a is equal to 120, when you go ahead and divide both sides by 6, you're finding out that a is 20. So there's one of our variables. You can plug that back in. 3 times a, 3 times 20 gives us 60. That sounds good. And then you can do that opposite angle as well. So angle J and angle L as opposites must be supplementary. So we must have 120 degrees over here to add on with that 60 and make it work. Then my angle M, look at that inscribed angle M, follow it out. This is going to be arc JKL. So that's going to take the 66 and the 110 together. you're talking about an arc measurement of, excuse me, 176 degrees. So again, my angle 4B has to be multiplied by 2 to get the measurement of my arc. Likewise, some of you may have also chosen to set it up where your arc 176 divides by 2 and set that equal to the 4B. Both of these equations are doing the same thing. So whatever your preference is there makes no difference. And so I'm just going to keep going here where I've got the space. So 8B is equal to 176. Divide that 8 coefficient on each side, so b is 22 then. We're going to plug back in now. 4 times b, 4 times 22 puts us at 88 degrees. And then if you use that opposite angle k, well, remember they got to have a sum of 180, so subtract that 88 from both sides, you'd be talking about 92 degrees at angle k. So those were lots of amazing angles that we have to deal with on page 1. As we continue on then here, number 5, some more angle rules coming into play for us. So this one, to find that angle x, I hope you realize this is an angle inside the circle, but it's not a central angle, it's not an inscribed angle. The only other kind of angle that we have inside the circle are the bow tie angles. So remember, those bow tie angles are the average, right? That angle inside is the average of those two bow tie arcs. So I'm going to take my 85 and my 57 that form the bow tie arcs, and they get divided by 2. So 85 plus 57 puts us at 142. Divide that by 2, and you're looking at x is equal to 71 degrees. Then we've got to find y. So your options are, in one situation here, let's go ahead and talk about y as, again, with the circle rules. This is another inside angle, so I can find the bow tie that's going to line up with it. So angle y has arc 148 and then uses that other arc of 70. So you could again find the bow tie arcs. 148 plus 70 has to divide by 2. And that would give you a measurement for y of 109 degrees if you did that with the bow tie arcs. But you might have also realized, okay, and so while I did just do that to practice with the circles, you might have seen that x and y are a linear pair. So if you already had known that your x was 71, you could have just figured out how much more did you need to get the 180 sum. 71 plus 109 would give you the 180 to make them a supplementary linear pair. All right, looking at number 6 then, I see an angle x. This is an angle outside of the circle. When you think about those angles outside of the circle, think about those flashlight problems. To find the angle outside of the circle, we've got to do the larger flashlight arc and minus the smaller flashlight arc, then we get to divide by 2. So x is my larger arc minus my smaller arc. And again, these are both of the ones that are inside that flashlight beam from my outside angle. Then we divide it by 2. So what is 115 minus a 25? And then you get to divide it by 2. You're talking about x equal to 45 degrees. And then on to that number 7. Angle 1, again, is outside of the circle. It's formed by 2 tangents. The last one was an outside angle formed by 2 secants. Now we're formed by 2 tangents, but it doesn't matter because it's still asking you to do a flashlight problem. This angle 1, and I'm going to rename it as y just so that I can have a variable to work with. We're going to take the larger arc in the flashlight beam, that's 220, subtract the smaller angle in the flashlight beam, that ends up being the 140, and then you divide it by 2. So we know that 220 minus 140 is 80, get to do that division, and so the y that I'm calling angle 1, that's going to be 40 degrees. Okay. Then this next section here in 8 through 13, we mix up some of the rules a little bit there instead of doing them all maybe separate or individually. So looking for angle A here in number 8. Well, I happen to notice that angle A is an inscribed angle. So I'd have to know about the intercepted arc, that's arc BC. To find out the size of arc BC, it matches up with central angle 132. So there's 132 degrees in that, right? Every pizza slice has the same amount of degrees at the point as what it has degrees in the arc. So that's your central angle. Then inscribed angle, think about twice as much ice cream in the scoop as what you want in the cone. So we're going to have to divide 132 divided by 2, puts us at 66 degrees for angle A. Now our number 9 wants arc BC. So for arc BC, let's see, what can we use to figure this out here? Well, I see that I've got some bow tie angles in here. So with that angle 124 being an inside the circle angle, I'm thinking about how 124 is equal to 128 plus some unknown arc that I don't know. We can call arc BC and X and divide that by 2. So you got to do some algebra here. We're going to multiply both sides of the equation by 2 so that we can clear out the fraction. Numerator and denominator simplifies to a 1. And then 124 times 2 puts us at 248 equals our 128 plus x. So subtracting that constant from both sides, you're talking about this arc of x as 120 degrees. Then angle C, let's see here. So to find angle C, I'm going to have to use that inscribed angle and its intercepted arc. I don't quite know what that is yet. What I do know is that I happen to have a semicircle. So arc ABC is a semicircle with 180 degrees. And I also hope that you see the 28 degrees as an inscribed angle. I'm going to have to multiply by 2 to get my arc. So 28 times 2 would put us at 56 degrees for arc BC. So find the difference then of what would make up our 180 degrees in the semicircle. You are now talking about 124 degrees for this arc AB. And remember that your arc needs to be divided by 2 because I want twice as much ice cream. So I'm going to divide by 2 to get my inscribed angle. This puts us at 62 degrees. So then in 11, this angle 1 is an outside angle. So I'm going to think about a flashlight problem. At angle 1 is going to have to use the big arc and the little arc within that flashlight beam. Problem is I don't know what this little one is yet. So I'm going to go ahead and call that L because I've got to find it. How will I do that? I'm going to use my interior angle and that bow tie arc. So this arc L that I want for my little arc, right? I'm setting it up so that 93 degrees is equal to the average of my bow tie arc. So that's 142 plus L divided by 2. Looking at 186 then equal to our 142 plus the little arc. Subtract from both sides. So my little arc is 44 degrees. This is good. Now we can go ahead and use that to find the angle 1. I'm going to label that as A. So remember, outside angles are going to be big arc minus little arc. So this is 142 minus 44, and then divide by 2. You are looking at this angle A, or angle 1, as 49 degrees. All right, number 12 has lots of amazing details going on in here. Solving for x. So first of all, I'm going to recognize that I have vertical angles here. So this angle that I'm going to put a polka dot in, that's the outside angle to the circle that we're talking about, but it is the same as the 9x plus 4. And with that outside angle, you can look for your flashlight beams. And so I've got to set it up then. My outside angle as 9x plus 4 is equal to, now I'm going to do the difference, the big arc, 26x minus 5, minus the little arc, find that little arc here within the flashlight beams, that's your 7x minus 2, and all of that gets divided by 2. Did you notice that I used parentheses around those expressions, right? Why did we do that? With that subtraction, you're going to have to distribute your negative through to both of them. And also remember that when you go ahead and clear out your fraction and you multiply by that 2 on both sides, you got to multiply everything on the left by that 2. So you will also need to distribute here. So fantastic demonstration of our algebra skills here. 18x plus 8 is then going to be equal to, and after we distribute and combine terms, 19x minus 3 then. So I can subtract my 18x from both sides, add my 3 to both sides, and I'm talking about x is equal to 11 there. And in 13, the angle DEF is outside of the circle. To work with it outside the circle, I'm going to think about that flashlight problem. So my angle, 5x plus 2, is equal to, and now we're going to do the big arc of the flashlight beam, 242, minus the little arc. The little arc is arc DF. I've got to figure out what that is. Remember, 360 degrees in a circle. I know what 242 is occupied, so this leaves me with 118 then for the other section of that. When we go ahead and solve, we can do that arithmetic on the right side. It's all just numbers. 242 minus the 118. Divide that by 2, and you'd be talking about 112 equal to 5x plus 2. Subtract that 2 from both sides. And then when you get to divide both sides by your coefficient of 5, x is equal to 22. There we are. Right. So down below then, as we look at 14 and 15, here in 14, we're going to find the length of the arc, right? Length of an arc. Remember, you want this to be in a distance idea. So you're talking about inches, centimeters, miles, something like that. So what fraction of the circle are we talking about? We're in arc EFG. Arc EFG is what we're looking at. And we had been told that angle EDF was congruent with angle FDG. So the 80 degrees is congruent again with another 80 degrees. So how many degrees are in this arc that we're talking about? Add those two together. That's 160 out of the possible 360 for a circle. And then you multiply by the circumference. Circumference, of course, you remember, or you looked up that it's equal to 2 pi r. So we're going to multiply by 2 times pi times a radius of 7, giving my answer in terms of pi here. So 160 out of 360 times 2 and times 7. You put everything except the pi symbol in there. This is talking about 56 over 9 pi. And again, the units, we're talking distance, we're talking about meters here. There we are. And the 15 then, same circle D, but in this one, it doesn't seem to tell us anything about knowing that we have congruent angles. That was only true on the 14 part. So same diagram, but I don't know that those angles are congruent. So what's the length of arc FHG? Starting at F, going past H, and all the way around to G. So how many degrees do I have in that arc? Well, all I know is that I'm not using the 80 degrees that's in there. So if I have to cross that out, right, 360 minus 80 puts 280 degrees in the arc that we care about. So my fraction is 280 out of 360 and multiply by that circumference. Multiply by 2 times pi times 7. This one says we can round to the nearest tenth. And so we can put everything into the calculator and round to 1 decimal point. So 280 out of 360 times 2 times 3.14 times 7. We're looking at 34.1911 when you get that out of the calculator. Again, tenth says 1 decimal point. Look behind it to tell you if it stays the same or rounds up, and that's a 5 and above. So we give it a shove. We're talking 34.2 meters for that arc length. Okay, continuing on then. 16 asks us to flip our mode into area of the shaded sector. This is connected with what we just did, so that area is going to be the fraction that we're talking about, the degrees out of 360, so 65 out of 360. And then remember the area formula, or look up the area formula for a circle, pi r squared. So times pi times a radius of 4 squared. This one says that we're given this answer to the nearest hundredth, so I can put everything into my calculator. 65 out of 360 times the 3.14 and times the 4 squared. We're talking about 9.07111 out of my calculator. So hundredths is my second place. Look behind to tell me if it's going to stay the same or round up, and that will stay the same. 9.07. This is area, so we're talking square inches. Area is always going to be square units. 17 then gives us another image to work with here. And so how many degrees are in the shaded section? Well, 360 for my whole circle, and I know 209 is taken up, so that leaves me with 151 degrees for that arc AB. So the degrees that I'm talking about is 151 out of 360 for the fraction that we are eating times pi r squared. So this is times pi 18 squared. This one says give it in terms of pi. So let's see, what is 151 out of 360 times the 18 squared? We're talking about 1359 over 10, 1,359 divided by 10, and we haven't used pi yet, so we put that back in. Again, this is area, so it's square units, and in this case, we're talking square meters. Okay. Then coming right on along here, and we've got some fun rules about those congruent chords that we can deal with. All right, so BC equals FG, and they're both equal to 16. So BC and FG are both congruent at 16. AJ is equal to 5. Now, because those two chords are congruent, we would also know that AK would need to be a congruent 5 as well. So that's the second part that we were asked about. AK is equal to 5. Because the two chords are congruent, their length away from the center is congruent. Then the CJ part is what else we need to find. And so where are we? CJ here, absolutely. We knew that the entire span was 16. Because it hit at a right angle, it was bisected into two congruent pieces, so that CJ is then 8. 16 divided by 2 gives us pieces of 8 and 8. Okay, I'm going to go ahead and erase this diagram so that I can relabel it with number 19, because certainly they get a little bit cluttered. So my end goal is to find arc BD. I'm told in here that CD is for x and BD is 2x plus 40. Now these two arcs are going to end up being congruent because the radius that intersects the chord of it makes a right angle, right? Chord BC cuts off that entire arc, and when it got hit by the radius at a right angle, it bisected it into two congruent pieces there. So my 4x has to equal my 2x plus 40. So 2x equals 40, which means that x is equal to 20. Got to plug back in now for arc BD. So this is 2 times 20 plus 40, 40 plus 40, puts us at, whoops, and look at that, I just renamed the arc to dB instead, but we can add them together and get 80 degrees for that. All right, then looking into number 20, find GK. Here we know BC is equal to FG, so the two chords are congruent. They both have a length of 20. We're looking for GK. And so GK is in here. Again, I know that this chord was bisected into two congruent pieces because the radius came down and intersected it at a right angle. So you're talking about GK being equal to 10. You got a section of 10 and 10 after that radius intersected perpendicularly. The last question in this diagram section, AK is equal to 8. KG is equal to 15. What is the length of AD? Well, this one is presented a little bit differently, but what do you know about AD? How would you label that? What would you call it? This is a radius of the diagram. Now, while it might not be drawn in here, what would you say about AG? Notice that segment AG is also a radius. So they have made a right triangle, because you can continue that perpendicular. So 8 squared plus 15 squared better be equal to the radius squared, which is the AD that I'm looking for, because it doesn't matter where the position is, the radius is the same everywhere on the circle. You might recognize that this is a Pythagorean triple, but if you don't, certainly do the arithmetic. 8 squared and 15 squared gives us 289, so that when you go ahead and take the square root on both sides, you find out that the radius is equal to 17, and that's the AD that we were looking for. All right. Now, our next image tells us that arc GI is equal to 55 and arc HJ is equal to 115. I need to be able to find the measure of arc GH. Now notice this arc is cut off by a chord that's congruent to another chord, so arc GH has to be the same as arc IJ. All of the arcs in this circle better have a sum of 360 degrees. So the 55 and the x and the 115 and the x together need to be 360 degrees. So when I do that algebra, 2x is equal to 190, divide both sides by my coefficient 2 then, and so I get 95, and that is indeed exactly what we had labeled as our arc GH. The arc was represented by x, so 95 degrees in it. All right, then getting into some more about segments. So in letter A there, to solve for x, I've got segments inside and outside of the circle. This one is where we're going to do the outside times the whole. So outside is x times the whole is x. And set that equal to, then my secant, outside times the whole. So outside is 5, and the whole is a 5 plus 10. So when we go ahead and solve, I'm talking about how x squared is equal to 75. Take the square root on both sides and make that factor tree, get this into simplest radical form. You're talking about 5 times the square root of 3. Part B, these segments are all chords, all contained within the circle. This is where we do that crisscross setup. So one segment has to multiply, that's the x times the 12, and we set it equal to, get that other segment multiplied by its pieces, 8 times 6, and then we go ahead and solve. So if 12x is equal to 48, when you divide both sides by coefficient 12, x is equal to 4. And then lastly here, part C, I see some segments inside and some segments outside. Again, this is going to be outside times the whole. So on my first branch, outside is x times the whole thing of x plus 4, and set that equal to, let's go ahead, and my second segment outside is 2 times the whole thing of 2 plus 4. So don't forget to distribute. So x squared plus 4x is equal to, then 2 times 6 is putting us at 12. So with that x squared and an x and a constant, you got to think about factoring. We're going to make this a quadratic setup. Move all the terms to one side, subtract that 12 from both, set it equal to 0. And then we're going to factor, right? X squared comes from that x times x setup. And you got to think about what two numbers can you multiply together to make a 12. That can also subtract from each other to make a 4. So I'm going to be using a positive 6 and a negative 2 because I know that positive 6 times negative 2 is negative 12. I also know that that positive 6 minus 2 gives me the positive 4x that we want in the middle. So set up your two mini problems. The x plus 6 has to equal 0 and the x minus 2 has to equal 0. So x could equal a negative 6 when you solve, or x could equal a positive 2 when you solve. These are our two possible answers. One of them makes sense, one of them doesn't. Which way is it? Well, think about it as you go to plug these things in. X has to represent a segment length. You cannot have a negative segment length, so x must be equal to 2. All right, winding down here to the last page of that study guide. So we're going to assume in the diagram that we have tangents if they appear that way. So any tangent intersects the radius at a right angle. You also know that the radius of 4 has to also match up and be a radius of 4. What are we going to do to solve this then? Well, you're looking at some Pythagorean theorem. So a leg of 4 squared plus a leg of 8 squared has to equal, my last one there is 4 plus x quantity squared, right? We've got to add these together to make that whole hypotenuse that gets squared. So the left side here with some arithmetic, 4 squared plus 8 squared has us looking at 80. Remember that this binomial squared is going to need you to think about it like a 4 plus x and a 4 plus x that are being multiplied together. So you're doing that double distribute process. 16 plus 8x plus x squared. And again, it's going to look like we can set up this quadratic. I want to move all my variables and all my terms to one side even, so it's set equal to 0. So, and I'm also going to go ahead and rearrange because I like to have that x squared term leading. X squared plus 8x and then minus 64 for us. So let's see what we can do then. Let's go make a new column. I'm going to have to factor this. X times x would give me the x squared. And let's see now, factors of 64. Now that's going to be, 64 could be a 2 and 32, which doesn't have a difference of 8. We could do a 4 and 16, but that's not a difference of 8. You can do a 4 and then an 8 times 8, but that wouldn't have the difference. So it doesn't sound like we're going to be factoring there, but we could put that into the quadratic formula, of course. So negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So working that radicand, 8 squared, and then the negative 4 times 1 times negative 64. Looks like we've got positive 320 in the radicand. And we're going to go ahead and simplify that. So this is going to put us at, let's see then, simplest radical form there. Negative 8 plus or minus 8 square root of 5. That gets divided by 2. And then remember that we can simplify, so the negative 8 divided by 2 would put us at a negative 4. Keep the plus or minus options, and then the 8 square root of 5 divided by 2 would be 4 square root of 5. So these are our two possibilities. We could be talking about x as a negative 4 plus 4 square root of 5, or you could be talking about negative 4 minus 4 square root of 5. If you take a look at those and investigate with them, you will find out that when you subtract negative 4 minus the 4 square root of 5, that's going to give you a negative outcome, and we can't have a negative distance. So the only possible answer for x is that negative 4 is adding on 4 square roots of 5. Okay. Then, as we continue along, the next question here in 25 about the water tower. We're standing 14 feet away from the edge of it. And so this line where we are measuring from is going through the center of that water tower. So we want to find the diameter of it. There's our job to find the diameter d. So with these measurements here, we're going to do an outside times the whole, so 26 times the 26 again, and set that equal to my other length. 14 is my outside, and then the whole thing is 14 plus the diameter. So set that up, and we get ready to solve. 26 squared is 676. And 14 times 14 when we distribute puts us at 196 plus the 14d. So we're going to subtract from both sides. We get 480 equals 14d. Divide both sides by our 14 coefficient. And we are talking about a diameter of 240 over 7. And my units on there are feet. Lastly here, let's see, we're dealing with some formulas, so let's make sure that we've got circumference is 2 pi r, circumference is also pi d, and area is pi r squared. Make sure you have those at the ready to work through these. So in 26, the circumference of a circle is given as 232.36. So if circumference is 2 pi r, plug that in, 232.36 equals our 2 pi r. I've got to divide both sides by 2 pi so that I can help to isolate the variable. I want to figure out what that r is. And so as we divide, radius is equal to 37. Use this now. The second part of the problem says calculate the area. So if area is pi r squared, then my area would be pi times 37 squared. And so if you're going for an exact answer, that's 1,369 pi square units, square feet in this case. If you were going for that in decimal format, because these directions didn't specify, you might have gone with 4,298.66, again, still in square feet. Then the number 27 right next to it, we are given a circle with an area of 784 pi square inches. All right, so with that area, when area is equal to pi r squared, plug in 784 pi. This is equal to pi r squared. We're going to divide both sides by pi. So 784 is equal to r squared. You're going ahead to take the square root on both sides. And so the square root of 784 is 28. That's equal to my radius. Question now wants to know what is the diameter of the circle. So diameter is 2 times the radius. You're doing 2 times 28. That would put us at 56. What kind of units are on a diameter here? We're talking about inches. I hope you're feeling a lot more confident now with all of your circles so that your test is going to go fabulously. Have a wonderful day. So, an alternate method that you might think about working with this problem is again going back to that idea about the right triangle. And so I know that my leg squared plus my leg squared has to equal the hypotenuse squared. So, what if I just call my hypotenuse as it is? What if I just label it as h squared? So, we can still do the 4 squared plus the 8 squared. That's going to give me 80 is equal to h squared. We know that to isolate that variable, we're going to take the square root on both sides. And so to write 80 out in simplest radical form, that's going to be 4 times the square root of 5. So that is the length now for my entire hypotenuse is 4 times the square root of 5. But I actually only want to know what x is in this question. So I've got to be able to figure out what is this section in order to take it away. Well, remember that the radius is the same on every circle no matter where it's located. So that section of x is the whole hypotenuse as a 4 square root of 5 minus the 4 radius that we are taking away.